Hello, welcome to CS101, Introduction to Computer Science. This is class 9. We'll talk about web servers, PHP, Ruby, and REST APIs. So what happens when you browse a website, right? So you're on your desktop or your laptop going to a website. So what typically happens is you open up your browser, you are actually loading this program from your computer, your hard disk to memory through your processor. And what's happening is that there's a server out there on the internet which has the website that you're looking for, right? And this is also run on the back end by a hard disk which is loading into memory running on a processor. So you have your local computer that's making a request to a server computer somewhere trying to get the data. And the data is in HTML format, and your browser, which is written in C or some other programming language, downloads that data, which underneath the hood is all really bits and bytes like we learned earlier. Okay, so the question is, now that that's how a website is loaded on your laptop or desktop, what really powers the backend? What really powers server software? And the idea is that there's a whole bunch of software that's running on the server that powers these services, the backend. So there are web servers that are sitting on a server that you are connecting to. These could be a whole bunch of servers such as Apache or Tomcat or Microsoft Internet Information Server, also known as IIS or Nginx. There's a whole bunch of other software, but these are the popular web server softwares. Then there's other things such as caching or proxy servers such as Squid or Varnish, and we won't talk about those today. And content delivery networks, which speed up delivery of images or videos from some endpoint on their services, so that it makes it easier and faster for users to download your content. And there's other services as well, such as database servers, web servers. We talked about that just now, and other servers. We'll talk about databases in the next class. So Apache is actually one of the most popular web servers out there. It's a non-profit foundation that actually takes care of multiple open source projects. But its first product was the Apache web server, which is an open source web server, and is today the most popular web server. And I believe Microsoft Internet IIS is the second most popular one. But Apache is very popular and runs on a whole bunch of websites and services and hosted services. So typically, most likely when you connect to the internet and you're talking to a web server out there, it's typically an Apache server that's responding to your request. And other server software is Microsoft IIS, which is built into Windows Server and also supports Microsoft's own programming languages. And it's often used for hosting and running sites built on Microsoft languages, but it also does support a whole bunch of other languages as well, such as PHP and a whole bunch of other languages and services. And there's Apache Tomcat, which is typically used for running Java applications on the server side. And then there's a newer one called Nginx. Not really newer, but it's grown popular recently, which is another open source alternative to Apache. It grew popular primarily for its strength in serving static files such as HTML, JavaScript, and CSS, and images and multimedia files, but it's claim to fame that it can handle a lot of requests for static media efficiently. Though Apache with the latest release has caught up in this regard, but Nginx as it's called, is also been growing in popularity recently. So given that these are the server software that run server-side applications, how do you build software that runs on the server? Well, most web applications are actually a combination of front-end and back-end technologies. So it's very rare to find a website these days that's written purely with the front-end or back-end. HTML and CSS and JavaScript, which we saw earlier, are used to render the front-end, the web page that you see in the browser. And there's a variety of programming languages and platforms as a choice, to run backend technologies that produce or interact with the front-end technology. So these run on top of or along the web servers and other backend architectures. So basically, these web servers and backend architectures help with making sure that your application is running. They just take care of that part, but they don't actually they're not actually the web applications you want to run. So you are actually building web applications yourselves if you're building server software that runs on top of those servers. So if you do run Apache as a backend server, it's a web server. It can serve HTML, CSS, JavaScript, and static files. But it's possible to build entire web applications such as Google or Facebook or any of the more useful web applications that you see through a variety of backend programming languages such as PHP, which is built into Apache or supported by default. There's Python, which can be enabled through installing some plugins such as mod WSGI, Ruby, and Java itself. So you have a choice of programming languages that you can run for your backend software. So let's talk about PHP a little bit. It's called PHP Hypertext Processor. It used to be called Pretty Homepage, and then it became a recursive acronym. It's a C-like programming language, and it's similar to JavaScript pages, where you have a PHP file that consists of HTML along with PHP code embedded in it. So basically, the PHP code is processed on the server, and then the rendered HTML is sent back to the end user. So when you view a website, whether it's built in PHP or JavaScript or Java Server Pages or any of these other technologies, you simply see HTML and CSS and JavaScript, but there is a server that's actually rendering this the HTML, the website that you see, and that is being generated through PHP actually. So why did PHP grow in popularity? You can actually see that according to at least one study, PHP is among the most popular server-side programming software out there. Why is that? It's probably because my take is that there's a whole bunch of shared hosting services out there. There's small and medium companies such as GoDaddy and DreamHost, which charge very small rates for hosting a website. These charge something like $4 to $10 a month, and they maintain minimal infrastructure to let people set up websites, right? So at this cost point, there's only like one set of services that can run on that shared hosting, which is Linux, Apache, MySQL, PHP, the LAMP stack, which is the minimal you need to run anything useful on the back end. So my take is that that's one reason why PHP has gotten so popular and powers a whole bunch of websites that are running on the internet today. So let's talk a little bit more about the LAMP stack. So LAMP really refers to Linux, Apache, MySQL, and PHP, all of which are really actually open source technologies. Linux is the operating system. Apache, as we saw, is the web server. MySQL is the database, which we'll talk about in the next class actually. And PHP is the programming language that enables you to build web applications that to kind of connect or talk to all these technologies. So it grew in popularity, especially among shared hosting due to its low cost and being open source. It enabled small and medium-sized businesses to set up their own websites at low cost, and it enables shared hosting services like GoDaddy and other domain and hosting services to provide low-cost hosting services. So basically a win-win situation for everyone, and that's why you see a lot of websites again, especially that run on shared hosting, that are built on PHP. Now add to that the fact that because PHP is so popular and runs on so many shared hosts, you have a whole ecosystem that's built around the PHP programming language. There's a whole bunch of open source as well as commercial software applications built on PHP. So the screenshot on the right just shows some examples. You have content management systems that you can use to build an entire website that are built on WordPress or Joomla or Drupal. You can build e-commerce websites using Magento or OS Cart, and there's other e-commerce and content management systems as well. There's also just a whole bunch of other software like Civi CRM for CRM applications, and many applications built on PHP. So what does PHP programming look like? Well, we looked at Java earlier and other programming languages. PHP is very similar to C rather than Java. There's a lot of function calls. Their names are actually based directly on C function calls. For a long time, PHP didn't actually have object-oriented programming concepts, but that's changed with the more newer versions of PHP. So a PHP code is actually embedded within HTML using PHP tags like this, like question mark PHP, and then there's an end question mark with braces. And the code again is rendered server side and sent to the browser. So the server executes the PHP code and sends back the rendered HTML to the user's web browser. So here's an example, code example that redirects the website based on browser settings. So this is a very simple PHP code that you see in the screenshot. It gets the language, HTTP accept language from the browser actually, and then determines what language the user can see and redirects them to a HTML page based on that user's language. So this is what PHP code looks like. Very quickly, we'll talk about Ruby on Rails. So Ruby is another programming language developed in the mid-90s. It wasn't actually very popular until Ruby on Rails, which was an extension of Ruby to build web pages, took off in popularity. The reason Ruby took off was because it made it easy to build database-driven applications and websites in the programming language. So people didn't have to do a lot to build, web-based applications, and Ruby really helped with that. So now a lot of other programming languages have adopted some of Ruby on Rails main strengths, such as active record scaffolding, which helps you really generate database driven applications very quickly. So Ruby, I would say, has kind of stalled in popularity. There's still a very big base of Ruby fans who develop, swear by Ruby and build websites in Ruby. But I would say that, its popularity has plateaued, and PHP and Python, are becoming more popular among smaller and medium-sized businesses, and Java and .NET technologies on the server side for more larger corporations. So that's typically how it is. But Ruby is definitely a fun programming language, very powerful, very sophisticated, and a lot of developers do swear by it. So, but it's also very popular because it was the first programming language to popularize some of the concepts that are used in building web-based applications today. So we've learned about programming languages. Let's go back a little bit to functions, right? So we learned about calling functions. Every programming language has the concept of functions. So all of these call local functions. So you write a function and you call it, and you can reuse that function. But sometimes programs need to make a remote procedure call. So oftentimes you need to call a function sitting on a different computer, so from the client to the server. So there used to be a lot of standards such as Corba and RPC and RMI, which do something similar to what's shown in this diagram. So you have a client computer that talks to a remote computer, gets the data, and processes it. It's kind of similar to how you, in a browser, you connect to a remote server, download a website, and you view the data. And the same thing happens in computer programming languages as well. It's except that a lot of these older standards were more complicated and required more setup time. So what happened is, when the websites, when the internet grew in popularity, programmers had an idea: why don't we make function calls over the HTTP protocol, which is the underlying protocol that runs websites today. A lot of programming languages already have very robust HTTP support. Again, HTTP is the protocol for the internet, for the World Wide Web, which browsers use. So it's very easy to set up web servers and endpoints these days. And what happens with REST is that this framework, or this protocol called REST, is that you simply use web servers and endpoints to serve data. Instead of HTML pages, you can have one programming language or one software program on one computer talk to a software program on another computer, which is set up as a web application. Instead of serving HTML pages for users to see, these endpoints serve data. So these are initially formats were in XML, which is extensible markup language, kind of a superset of HTML, but now mostly another language called JavaScript object notation, JSON, which is kind of a JavaScript sort of based, it's not really language, but an object notation. So the idea is that your program calls a web server somewhere and gets, instead of HTML data, it gets either XML or JSON, and it processes that. And again, HTTP and REST APIs have mostly replaced other remote function calls, such as older technologies such as Corba and things like that. So here's a REST example. So let's say you want to get a list of cars, right? So the idea is that you call a web server, your programming language, your program calls a web server called api.co/v2/cars. The idea is that you would get a list of all cars, and there's different protocols within HTTP itself: get, post, put, and delete. You don't typically see these when using a web browser. A web browser typically uses get. It uses post. So when you're submitting a form, right, you're logging into a website, sending an email, etc., and you're submitting some data through a web form, that's a post method. And there's also put and delete. So typically, as a user of a web browser, you don't see it, but behind the scenes, a browser is submitting HTTP get and post. So your programming language can use a HTTP GET and POST to get the list of cars, or to create a new car in the database. So you can post to the same HTTP web URL, and you can create a new car. You can put, you can delete, and basically you're calling a function, except you're calling from one computer to another computer, and the server makes sure that it can, receive these requests and handle it properly. Similarly, the same thing with the REST example. So if you want to get a specific car rather than a list of cars, you can use the same thing. You use get, post, put, and delete, or get, put, and delete. And the idea is that instead of api.co/cars, you could say /cars/ a specific car. So then you get data for that specific car, or you can update it, or you can delete it. So this is kind of the REST paradigm. This is kind of the how REST endpoints are set up, and how you can build REST endpoints and allow programs to talk to each other over REST. And the core idea, the reason why REST is so popular, is because you can have a common communication from server to any client. So any client, which is a mobile app or a web application or a desktop app, all of these can connect to a web-based REST API, and you can build multiple front-end platforms with the same backend. So all devices will authenticate and use the same backend service. So instead of building multiple server software to power your mobile app and website and desktop application, you instead build a REST API, and it can be used in common. So REST is a very popular and powerful programming paradigm that lets you build remote services, and allows you to build software programs that communicate with each other over the internet.